Okay, next we're going to go to the application inspection capability via MPF on the ASA, which is going to be likewise the same scope pretty much as we did on the iOS zone-based policy firewall. Configuration-wise, going to be a bit similar likewise as the iOS zone-based policy firewall. So just like in the case of zone-based policy firewall application inspection, this allows traffic inspections at OC layers 5-7 in order to provide a higher level of security. It will affect clearly the router firewall performance, as it was the case of the router zone-based policy firewall as well, because the ASA now has to go at the layer 7 and look and pay and do some inspections at that level, which is going to consume more resources on the firewall. Just like in the case of iOS zone-based policy firewall application inspection, benefits are the same. We can prevent application tunneling. We can make sure that whoever sends HTTP traffic to the firewall, for example, that's going to be pure native HTTP traffic. It's not going to be like messenger traffic over HTTP. So you can prevent application tunneling. We can provide a basic level of security at the application layer. Like it was the case with zone-based policy firewall, we can restrict the number of recipients within an SMTP conversation, or we can perform URL filtering. Of course, depending on which application we inspect, we have other options in there. Or we can prevent malicious application layer traffic, because of course this doesn't mean that by doing application inspection, the ASA or the iOS zone-based policy firewall are doing some kind of antivirus or anti-malware or whatever. No. So then how does this feature blocks some malicious traffic? Because you may be, let's say, you may be aware that a specific SMTP or FTP command has a vulnerability which allows an attacker to send some kind of malicious traffic, or HTTP method has a vulnerability as well. So because you can allow those methods, those HTTP methods or those SMTP, FTP commands, then you're gonna make sure that because those options cannot be used by those protocols, it means that the attackers cannot make use of those vulnerabilities to inject some malicious traffic over those protocols. Now configuration-wise, it's gonna be the same like in the iOS zone-based policy firewall. We optionally configure regex, not via a parameter map, but just like a regex function, which we can use that regex in different type of application inspections. Depending on which type of application inspection we perform, regex can be required or not. Then we configure the application inspection layer 7 class map, where we match on traffic, on the application header of traffic we want to inspect the layer 7. Then we build the layer 7 policy map, and in the policy map, just like in the case of iOS, we attach the layer 7 class map, and we define the firewall policy for this application inspection. So it means that if traffic matches the rules configured in the layer 7 class map, what do we want to do with that traffic? Drop it, reset it, or just log a message? Of course, the difference between drop and reset is that on a reset, the ASA is going to send a reset to both source and destinations, to both the client and the server in that TCP session, for example, while upon a drop, the ASA is just going to silently drop the packet. So that's the difference between a reset and a drop. So with a drop, the ASA doesn't send resets to the source and destination of the IP flow, which is going to drop. And the last step is going to be to enforce the application inspection firewall policy, which it means to apply the application inspection policy map, which just like in the case of iOS zone-based policy firewall application inspection, is going to be applied by nesting the layer 7 policy map within a layer 3-4 policy map, just like in the case of iOS zone-based policy firewall. Verification-wise, so additional to regular MPF verifications, we just say show service policy inspect in the protocol. Like show service policy inspect HTTP or FTP, depending on for which protocol we have configured application inspections. Now looking on the ASA, conf-t, ASA supports application inspections for a lot of protocols. So it is for DCE, DNS, SMTP, FTP, GTP, HTTP3, HTTP, Yahoo Instant Messaging, ESP, for IPv6 like IPv6 like the neighbor discovery, MGCP, NetBIOS, radius accounting, RTSP, ScanSafe, SIP, Skinny. So for a lot of course, ScanSafe, it's not a protocol. ScanSafe is going to be Cisco's cloud web security. That's an exception. But otherwise, all of them are IP protocols for which the ASA supports some kind of application inspection. In our use case, we're going to do the same thing as we did on the iOS. So looking back at the diagram, we're going to make sure that we're going to configure PCB's DNS server to be routed free, the DNS server. We're going to make sure that both, for example, Cisco.com and test.com, both of them map the loopback routed free to 55553. And then we're going to configure on the ASA via MPF. We're going to configure on ASA, we're going to configure HTTP inspection so that if traffic goes to Cisco.com, it's going to work. So traffic flowing from PCB to Cisco.com is going to work, it's going to be green. But traffic flowing to test.com is going to be dropped. So that's going to be our use case. So first of all, let's make sure, let's configure on PCB, let's configure routed free to be a DNS server. On PCB, let's make routed free a DNS server. Let's configure free then as a DNS server with those entries, and let's make sure that traffic from PCB to the loopback of routed free is allowed by the ASA inbound ACL. So let's first go on PCB and configure the routed free's loopback as a DNS server. Change adapter settings, and let's right click the lab connection, properties, TCP IPv4 properties, and let's make the DNS server to be 5553. Okay, close. Let's go on routed free and make it a DNS server. Show run include DNS, conft IP DNS server, and IP host. Let's configure those two entries. IP host www.cisco.com maps to loopback routed free, and IP host www.test.com maps to the loopback of routed free as well. And of course, let's make sure that HTTP server is enabled. And there we go. Now let's make sure that ASA-HTTP allows DNS and HTTP traffic to flow from PCB to routed free. So show run access list inside N. Currently, my configuration allows to the loopback of routed free only ICMP traffic. We want to allow also DNS and HTTP. Let's put two more lines in here. So we want to allow traffic from the source. We want to allow TCP traffic on port 80 from VLAN, from PCB subnet to the host to the loopback routed free on port 80. And we also want to allow traffic, DNS traffic. So permit UDP traffic from the subnet of PCB to the loopback routed free on port 23. That's going to be DNS traffic. So now let's confirm that by going on PCB and doing NSLOOKUP, we are able to resolve both of those domain names, both of those host names, NSLOOKUP. And we say www.cisco.com resolves over to 5553, and www.test.com resolves likewise over to 55553. Let's say exit. Now let's make sure that initially I can browse to both cisco.com and test.com. www.cisco.com. It should prompt me for authentication on the web page on a web server of Route.fi. I got connected and the site says level 15 access. So I need to authenticate. Let's see if authentication works. Cisco. Otherwise, we're just going to move on. It's good enough that I got connected. This confirms that the ASA allows the traffic. Doesn't matter. I'm not going to fix that up. And then let's go to test.com, which likewise should work, because I go still to the loopback, and there we go. I'm being asked for authentication. Well, this confirms that initially going to test.com and cisco.com, because ultimately both of them resolves the loopback of fee. Traffic is being allowed by to both URLs. Now let's go on the ASA and configure the ASA to drop traffic destined. Let's configure the ASA for application inspection, so that if traffic goes to test.com at HTTP level, it is going to drop it. So let's go on ASA tree and say conft. Let's first define a regex. Let's say regex for URL filtering, and I'm gonna say that I'm matching on, let's say, test.com. Show run regex, because I'm gonna match on the host. So the SA by default is gonna put, when you define a regex, is gonna put in there the double commas. So either you configure it or you don't configure, it's gonna be in there by default. So I'm gonna filter traffic going to test.com. Well, actually, I've done something wrong clearly, as I did also on the iOS. The same mistake I remember now, because the dot has a special meaning in regex, means match on anything. So if I want to match on the dot in the URL, we have to actually say I want to match on test/.com. I'm telling the SA that I wanted to match on the dot exactly, not on anything, which was likewise configured in here. So shown on regex, we should see now in the proper format, and there we go. Which this means that this regex is going to match on test.com exactly. Then we say show run class map, and let's configure a class map of type inspect for HTTP. So let's say class map type inspect HTTP, give it a name cmap HTTP, and I'm gonna say match request, like we did on iOS, match request header host and the regex of URL filtering. Let me put this in. I'm gonna put this all of the information in Notepad. So then I'm gonna walk you through the whole configuration. So show run regex. Let's put this in Notepad, and then show run class map type inspect HTTP. I'm gonna put this in Notepad. So I match with the regex on test.com. Then in a class map of type layer 7, I'm inspecting HTTP traffic, and I'm saying that I'm gonna match on the request method, which is when the client sends request something, and I'm looking the header, and I'm gonna match on the host entry of test.com. So if the access code is gonna be test.com, I'm gonna match with this class map. Then I'm going to tell the ASA what to do if it's going to match on that test.com. Policy map type inspect HTTP is going to be pmap of type HTTP. I'm going to reference that class map, cmap HTTP. So if traffic matches on test.com, then what do I want to do? Let's say drop connection and log a message. So show run policy map of type inspect HTTP. This is what I want to do. So as I'm matching on test.com at URL level, I want to drop traffic going to test.com. And the final step is to enforce this configuration. So just like it was the case with iOS application inspection, the application inspection cannot be applied by itself. So you can only the layer 3 or layer 4 policy map can be applied globally or at interface level on the ASA, because those policy maps are going to be controlling firewall policies, layer 3, layer 4 firewall policies. If I want DPI inspection, I have to attach my layer 7 policy map inside a layer 3, layer 4 policy map and matching on a class map in there, like it was the case with iOS. So now I have to configure another class map which just matches on web traffic. I'm gonna say class map HTTP traffic, and I'm gonna say match protocol match port TCP 80, which means I'm gonna match on all traffic on port 80. Let's configure this. Equal 80, which you know it's HTTP. Then we go under our policy map, which is globally applied, which is the policy map global policy. We reference this class map. We say class HTTP traffic, which matches on HTTP traffic because it's TCP port 80. And then we say, for this traffic which is HTTP, I want to perform HTTP inspection, but I also want to do DPI application inspection, which means I'm going to attach in here the layer 7 policy map. Configuration is pretty similar like it was the case with iOS application inspection. So what I'm doing is very simple. I'm building a class map of type layer 3, layer 4 to match on my traffic, HTTP or FTP or SMTP or what other kind of application inspection do I want to perform. Because in my case, I want to do HTTP inspection. It means I gotta configure a class map of type layer 3, layer 4 where I'm matching on HTTP traffic. Then I'm configure a layer 3, layer 4 policy map. In my case, I'm making use of the default existing one. And then I'm referencing in this policy map, I'm referencing the layer 3, layer 4 class map. And I'm saying that for that traffic on port 80, for all traffic on port 80, I want to inspect that traffic as HTTP traffic. But also additionally, I want to do DPI inspection as that layer 7 policy map states. And then to look further on the blocks, the layer 7 policy map states how is this all connected in here on the layer 7 inspection, is that first I'm using a regex to make granular matching on the URL host. That's a regex. That's the first block, and then I call the regex inside the layer 7 class map, where I'm saying if traffic matches that regex, which means if I'm matching on an HTTP request and in the header the accessed host is test.com. That's what I'm saying with that command. What do I want to do? And then I'm building the layer 7 policy map where I'm referencing the layer 7 class map. And I'm saying that if traffic matches that class map, which means if I'm going to test.com, then I want the firewall to drop the connection and log a message. So you configure the the application inspection as a regular regex class map policy map of type inspect for that protocol. Well, the regex helps you to better match on the application header. The class map of type layer 7 allows you to match on layer 7 header, and then the policy map of type layer 7 tells the action for traffic being matched at layer 7, and I chose drop connection and log. But then to enforce the policy, because in my case I want to do HTTP inspection, I need a regular layered 3 layer 4 class map where I have to match on that exact type of traffic, like HTTP traffic. And I've referenced that layer 3 layer 4 class map in a regular layer 3 layer 4 policy map. And I'm saying that for that traffic which matches that class map, which means for traffic on port 80, I want to inspect that traffic as HTTP, but also do application inspection as the layer 7 policy map states. So that's how things are connected one to another. Now if we go on a CLI and we say show service policy, inspect HTTP. So configuration wise, as we saw, we say show run regex. It's very simple, show run regex. Then show run class map type inspect, and the protocol show run class map type inspect HTTP. We see the HTTP application inspection class maps, and show run policy map of type inspect HTTP. And then we see the layer 7 policy maps, and then clearly show service policy to see the what we have enforced the configuration show service policy inspect HTTP. And it shows me that for this policy map, layer 3 layer 4 policy map called global underscore policy, I'm doing HTTP inspection for traffic match in that class map, which is traffic on port 80, and I'm saying I'm gonna inspect HTTP traffic as the layer 7 policy map states, which we know that the layer 7 policy map states that if traffic matches on the layer 7 class map, which means if it descends to test.com, I'm gonna drop the connection and log a message. Exit. Let's say clear logging, buffered. Let's go now on PCB. Let's close the browser. Let's make sure that if I go to cisco.com, it is going to work. And if you go in the connection table of the ASA, show connection, protocol TCP on port 80. This should show up in there. Show connection, protocol TCP. Actually interesting, it doesn't show up. Let's go on Varadv and actually configure the authentication. IP HTTP authentication local, and let's make sure that the username of Cisco has a privilege level of 15. Do show run, include username, and has a level of 15. So let's authenticate with Cisco on a web server of Varadv. Say OK. I'm connected successfully. Let's go and look on the ASA table, and let's say show connection protocol TCP. That's interesting, it doesn't show up in the state table. Let's say refresh. Show connection host. Show connection not long. Show local host for, let's say, 1.10.33.10.10.33.100, and it has 0 TCP flows. Clear connection and clear local host. Let's kill the browser from PCB and let's open it and go again to cisco.com. Cisco. Connection succeeded, show connection. For whatever reason, it doesn't show up in the connection table. This is clearly not expected. Because I am connected to router 3. Okay, we're going to look at this problem in a couple of seconds. Let's confirm that for the moment. Let's confirm that accessing cisco.com works and accessing test.com does not work. So connection was reset. If we say show log and look at the end of the logs, we should see, there we go, log message saying that packet was denied class 27 because I matched on the class map of CMAC HTTP layer 7 class map, which was attached in the layer 7 policy map of PMAP HTTP. We matched on a header, which was test.com, and dropping connection from inside to outside, and also we have sent a log message, and the access to URL was test.com. Well, cisco.com worked. Of course, that doesn't send a log message. That didn't do any log messaging. But we saw that access to cisco.com worked before. So that's a confirmation that our policy works. Also, if we say show service policy, inspect HTTP, we should see, there we go, that we have dropped one session, because only one session was in there. We have inspected a lot of packets back and forth, 122 packets, because some of them were allowed to cisco.com, and only one drop because one session was initiated to test.com and that session was dropped. And of course, also log message was issued. Out of curiosity, let's say telnet 5553 on port 80. I should be connected. Let's go again and say show connection. Yeah, there we go. Now it shows up. So it was just something temporarily in the ASA. For whatever reason, I didn't saw the entry in the connection table. Now I see it. It is between ASA, between PCB and router 3. Of course, on router 3 is port 80, which is the HTTP port.